chemical reactions could be reversible or irreversible. So, chemical reactions are reversible when they do not reach completion, and when they reach completion, then they are called irreversible reaction. So, what do you understand by completion of a reaction? Completion of a reaction means that reactant is 100% converted into products. If reactant is 100% converted into products, we say reaction is complete. If reactant is not completely converted into products, certain amount of reactant is left, certain amount of product is performed, then such reactions keep going on for a long time, and such reactions are called reversible. That means reactant will be converted into products, at the same time some product will be converted into reactants. Alright, so we do have reversible as well as irreversible reactions in nature. For example, reactions which have precipitation formation or precipitate is forming, such reactions are usually irreversible reactions. For example, we have few examples out here. Barium chloride reacts with Na2CO4 to form barium sulfate precipitate. So this reaction is our irreversible reaction. Barium sulfate is a precipitate, so it settles down at the bottom. Reaction keeps moving forward until it is completed. Same way, KClO3 gives KCl precipitate. AgNO3 NaCl react to give AgCl precipitate. So precipitate is formed, so reaction is completed. And we have few reactions out here which are reversible. PCl5 converts into PCl3 as Cl2, and at the same time some PCl3 combines with Cl2 to give back PCl5. Alright, so both the direction reaction keeps moving, and such reactions are called reversible reactions. Alright, state of chemical equilibrium, what does this mean? This means that rate of forward reaction, for example, if I take a reaction PCl5 converts into PCl3 plus Cl2, rate of forward reaction is Rf and rate of backward reaction is Rb. So at equilibrium what is going to happen is, at equilibrium we have a rate of forward reaction Rf equals to rate of backward reaction Rb. Alright, so rate of forward equals to rate of backward reaction. This condition is known as equilibrium condition. Alright, what happens at equilibrium? Firstly, you can see the speed of forward reaction is equals to the speed of backward reaction. Another thing is, once equilibrium is reached, then the amount of reactant and amount of product does not change. It becomes constant. It may be equal or it may not be equal. Alright, anything is possible, but whatever the amount is at equilibrium, it will not change from there, right? Unless temperature is changed. Alright, let's see. Few graphs we have over here. So check out concentration versus time. I told you concentration once equilibrium is reached does not change, whatever it is, right? So you can see from here equilibrium is reached, so concentration of reactant and concentration of product becomes constant. Whatever it was, it becomes constant. In this again, once equilibrium is reached, concentration of reactant remains as such, it does not change with time. Same with concentration of products, it becomes constant. And in this graph you can check out, it is talking about rate of reaction, rate of forward reaction and rate of backward reaction becomes equals to each other at equilibrium. So this is equilibrium condition, this is equilibrium where rate of forward becomes equal to rate of backward reaction. So these are the explanations for equilibrium condition.